Okay, this is our last section in Chapter 2 on square roots of rational numbers. This is grade 9 version. So rational numbers now, we understand that rational numbers can be things like whole numbers, they could be integers, they can be fractions, they could be mixed fractions, they could be improper fractions, they can be repeating decimals, and they can be terminating decimals. In grade 8, we did learn a little bit about square roots. Now, just to refresh your memory, in grade 7, when you learned about pi r squared, you learned about calculating the area of a circle using pi r squared. And it would be, let's say the radius was 4. Then it was 3.14 multiplied by the radius squared. And you learned that when you do bed mass with squaring a number, you do your squaring first. What is, Andrew, what's 4 squared? 16. A lot of people who make a mistake say it's 8. But remember, 4 squared means taking the number 4 and multiplying by itself whatever that exponent is. In this case, 2, which means it's 4 multiplied by itself twice, which means the answer is 16. That's what squaring a number is, right? Squaring a number. That's a review from grade 8. And square rooting is the opposite of squaring. So if 4 squared equals 16, then we would say the square root of 16 is equal to 4, right? Remember that from last year? This is squaring a number. This is square rooting a number. This is squaring, and that's square rooting, right? Okay. So with the next section, what we're really going to do is we're going to learn how to do square roots with terminating decimals. We're going to learn how to do square roots of fractions, right? We're going to learn how to calculate these things. So in our first example, I'll show you now, it says estimate and calculate the area of a square photo with a side length of 7.1 centimeters. So our first question here on our sheet of our exemplars of questions that we're going to use to solve these wonderful questions from section 2.4. It says, estimate and calculate the area of a square photo whose side length is 7.1. So the first thing you're going to need to do here is just kind of draw it. And since it's a square, we're going to put these little lines here to say that all of those sides are the same. Now, does anyone know what the formula is for the area of a square? Hayden, what is it? Side times side. So area equals the side times the side. Or, since that would be maybe a grade 7 or grade 6 formula, the one we're going to use, since side times side is a side multiplied by itself, we're going to use the formula side squared. That's what side squared means. It means side multiplied by itself. Okay, so area equals side squared. So I'll write that down again, area equals side squared. First step is write your formula. Second step is to substitute 7.1 for the side length. Okay, so your area equals 7.1 squared. Now we have to estimate 7.1 squared first. So the way we're going to do that is we're going to use a number line. This is how we're going to estimate. What is 7 squared? 49. I'm going to put 49 above here. What would be the next one we know? 8 squared, which is 64. All right. Now, if I gave you a red dot and said, please place that red dot on that number line so that you show me where 7.1 squared would would you think it would be right here? Would that be reasonable? No. Be much closer to, well, that was a very gregarious no. Would you agree with that one? Probably right around there. So since now we have our number line kind of created, we could ignore the squares and we could just focus on these numbers here. What number do you suspect that red dot would be? Would you guys say the square root of 50 or the square root of 51? Okay, so if I say that's 51, then therefore 7.1 squared is 51, roughly, according to my number line. So my estimation equals with a dot above it is going to be approximately, I'm going to guess 51. And I'm going to put centimeters squared. That's my estimation. Okay? Now my calculation will be area equals side squared, area equals 7.1 squared. And then I'm going to guess I'm going to actually calculate 7.1 squared. Grab my calculator. What is 7.1 squared? Now you can either do 7.1 times 7.1 and press the equal sign, or clear. You can go 7.1, and if your calculator is lucky enough, you actually have a square button on it. You press it, and it says 50.41. 50.41 centimeters squared, and that's how we're going to do it. Okay. All right, I'm going to give you another one. You guys try this one. Same question, different expectation. This time, the square has a side length of 4.4 centimeters. I want you to estimate and calculate the area of that square. Okay, so hopefully if you're watching this video at home because you're reviewing for a test or you missed class today and you're just practicing, you press pause, you tried the question, and you're anxiously awaiting to see if you did the work correctly. So the first thing I'm going to do is estimate. And when we estimate, I'm going to think what 4.4, the area is going to be side squared, which is going to, area is equal side squared, which is going to be 4.4 squared. To estimate, I'm going to use my number line. I know that 4 squared is 16, and the next one I know is 5 squared is 25. And if I take this black dot and approximate 4.4, what would the middle be? That would be 4.5 squared, correct? So 4.4 squared is going to be just a little bit more that way, correct? What's a good guess for what 4.4 squared is? Would anyone say 20? 20 is a great guess, isn't it? So we're going to say the area is approximately equal to 20 centimeters squared. And we're just going to write it with the equal sign with a dot above it. And then our calculation will be area equals side squared, area equals 4.4 squared, and our calculation will be, with a calculator, 4.4 squared, so 4.4 squared is 19.36. Pretty close. And that's how you estimate and calculate the squares of terminating decimals, just like that. Okay? Any questions on that? Our next exemplar says, is each of the following numbers a perfect square? So remember, a perfect square means that it's like 16 is a perfect square, as an example. 16 is a perfect square. Why? Because there is a number that when multiplied by itself gives you 16, right? So is 121 over 64 a perfect square? Meaning, is there a fraction that multiplies by itself to get you 121 over 64? What's your feeling say? Well, let's look at it. So if this is, the answer is yes, and I'll tell you why. Because is there a fraction that multiplies by itself to get you 121 over 64? The answer is yes, there is. What would my numerator be if I multiply the numerator by itself to get 121? 11. So we're going to put 11 here and 11 here. And what's the denominator going to be? It's going to be 8. So therefore, 11 over 8 squared is equal to 121 over 64. Or the square root of 121 over 64 is going to be equal to 11 eighths, or 1 and 3/8. Does that make sense to everybody? 11 eighths squared means, and I could just kind of put it down here, 11 eighths squared means 11 eighths times 11 eighths, and we know our fractions. That's going to get me 121 over 64. Okay? Or I can reverse that and say the square root of 121 over 64, meaning what fraction multiplied by itself is 121 over 64. Well, we did the work right here. Therefore, the square root of 121 over 64 is 11 over 8 as an improper fraction. And I can reconstitute that improper fraction back to mixed and say 1 and 3/8. Okay? Any questions on that? So yes, 121 over 64, an improper fraction. It is a perfect square because there is a number that multiplies by itself to get you that. Second question, 1 and 2/10. Is that a perfect square? Well, now we're running into a little bit of difficulty because we have a decimal that we don't know. We know how to do the fraction part. It makes a lot of sense why that's true. So what we're going to do is I'm actually going to change this decimal into a fraction. So how do I write 1.2 as a fraction? 1 and 2 over 10. 1 and 2 over 10. But I don't want to deal with mixed fractions. I'm going to try and make this into an improper fraction, which is going to be 12 over 10. Now the question can be, is 12 over 10 a perfect square? Let's think about what we did back here. So for 121 over 64, we said yes. But is there a fraction that multiplies by itself to get you 12 over 10? No, because there is no number. 12 is not a perfect square. What times what is 12? There is no number that multiplies. 6 plus 6 is 12. But there is no number that multiplies by itself to get you 12. Likewise, there is no number that multiplies by itself to get you 10. So therefore, 1.2 is not a perfect square because there is no fraction that multiplies by itself to get you 12 over 10. Does that make sense to everybody? So 1.2, what I did here, just to show you again, if I'm going to tell you if it's a perfect square without a calculator, I first have to think about 1.2 as a mixed fraction, 1 and 2 tenths. Then as an improper fraction as 12 tenths. Ask myself, is there a fraction that multiplies by itself to get you 12 tenths? The answer is no, and therefore 1.2 is not a perfect square. And the last one we had here was 0.09. 0.09. What number is 0.09 as a... So what number is 0.09? How do I read that, Emma? What would I read? You don't know? Chloe, how would I read 0.09? 9 what? Not 9 tenths. 9 hundredths, that's right. So the first thing I'm going to do is write it as 9 over 100, because that's what it is. And then I'm going to ask myself, is there a fraction that multiplies by itself to get you 9 over 100? Can you say yes or no there is? Is my numerator possible? Is there a number that multiplies by itself to get you 9? What number is it? 3. My denominator, is there a number that multiplies by itself to get you 100? And that is 10. So is 9 hundredths a perfect square? Yes, it is. So here's what I say. I say, yes, it is. And I can say one of two things. I could say the square root of 0.09 is equal to what number? Well, I want to say 3 tenths, or a better form, since this was a decimal, I want to write 3 tenths like this, right? Does that make sense? And just to double check our work, I'll grab my calculator and say, what is the square root of 0.09? If I press the square root button, which exists right here, right below the square button, it should say 0.3. And it does. Okay? So square root of 0.9 is 0.03, or 0.3. Okay. Any questions on those two? Let's try one more. All right, here's a tricky one. Is one, oh, that's not what I wanted. What's that all about? Is 1 and 7/9 a perfect square? Is 1 and 7/9 a perfect square? Go ahead and work that out. See if you can figure it out. And let me know if 1 and 7/9 is a perfect square. I'll press pause and you guys can work it, and then we'll press unpause. Well, this is interesting. So what kind of fraction is 1 and 7/9? It's a mixed fraction. And what I need you to make a note of, if you're going to determine whether or not a fraction is a perfect square, you always need to examine it as either a proper or improper fraction. You cannot use a mixed fraction. So what is this as an improper fraction? It is 16/9. So is there a fraction that 1 multiplied by itself gives you 16/9? That's really the question we're asking ourselves. And is there a fraction that multiplies by itself to give you 16/9? Yes, there is. Numerator is 4, denominator is 3, and therefore 1 and 7/9 is a perfect square. So 4/3 squared is equal to 1 and 7/9. I could say that one, can I? 4/3 times 4/3 is going to equal 16/9, which is going to equal 1 and 7/9. Or I could also say the square root of 1 and 7/9 is equal to 4/3. Or square root of 16/9, if I wanted to, is equal to 4/3. Or 1 and 1/3. Let's try one more before we go on. Is 2.25 a perfect square? Meaning, is there a decimal that multiplies by itself to get you 2.25? Go ahead and see if you can work that out. I'll give you a hint. If you're going to do this without a calculator, you need to change 2.25 to a fraction and then an improper fraction. There's your hint. Go ahead and try that. All right, let's try this without a calculator. So the first thing you need to say is, what number is this? And we're not going to keep it as a decimal. We're actually going to change this to a fraction because it's easier to calculate whether it's a perfect square or non-perfect square in fraction form. So this is 2 25/100ths, which has a mixed fraction. Going back to your grade 6, when you studied decimals to mixed fractions, you learned how to do that. Those two numbers are the same thing. But like we said up here, I don't want to keep mixed fractions if I'm going to determine whether it's a perfect square. I want to change that to an improper fraction. What's that as an improper fraction? 225 over 100. Now I will definitely understand if you're like, I don't know if 225 is a perfect square because I don't know that far up. But 225 is a perfect square. What times itself is 225? 15. So what fraction times itself is equal to 225 over 100? The answer is 15 is your numerator because 15 times 15 is 225. And 10 times 10 is 100. So therefore, the two things we could say is this, is that 15 over 10 squared, or what's 15 over 10 as a mixed fraction? 1.5, well, as a fraction though. Or 1 and 5/10, but in lowest terms. 1 and 1/2 in lowest terms. Or 1.5 squared. All three of those things is the same thing. 15 over 10 is the same thing as 1.5, which is the same thing as 1.5. All of those squared is going to equal 2.25, or 2 1/4. Is everybody okay with that? That makes sense to everyone? The alternative way of saying that is this. I can reverse it and say the square root of 2.25 or the square root of 2 1/4, meaning what fraction or number, is equal to 1.5 or 1.5 or 15/10. We good on that? Gracie? A really good point was this. Somebody just said, Gracie just said, the 225 over 100. She actually, before she changed it to an improper fraction, she reduced it down to 2 1/4 first, right? It still works because watch what happens. What's 2 1/4 as an improper fraction? It's 9 over 4, right? And what fraction times itself is 9 over 4? The answer is 3 over 2, or back to this, 1.5, right? It still works out. You still get the same answer, the right answer. Okay, that's a kind of a complicated one, but it's not so bad once you practice it. Let's go on to our next exemplar. Maybe. Okay, now we have the reverse of it. So we have evaluate 2.25. So we just did this exact one, so it's going to be really easy. So for A, what is the square root of 2.25? I'm going to say, what is the square root of 2 and 25/100ths? Or, as Gracie just did, the square root of 2 and 1/4, if I reduce it to lowest terms. Can I calculate that because it is a perfect square? Yeah, it's 9 over 4. Which means what fraction times what fraction is 9 over 4? The answer is 3 over 2. And therefore, the square root of that is 1.5. Or 3 over 2, or 1.5. We just did that one, so it's not so complicated. Okay, let's look at B. Let's look at B. Evaluate the square root of 0.16. First of all, how do I read 0.16? I shouldn't read it as 0.16. Danny, how should I read 0.16? 16 tenths, right. So what is the square root of 16 tenths? What is the square root of 16 tenths? That's what 16 tenths looks like, isn't it? Right? Or sorry, not 16 tenths. Did I say 16 tenths? Danny, why did you say 16 tenths? Oh, I said 16 tenths. Danny didn't say 16. 16 hundredths, which is incredibly important because it's now 16 over 100. You'd think I'd know decimals by now, teaching it for 25 years. What fraction multiplied by itself is equal to 16 hundredths? Abby? Not here. CJ, what fraction multiplied by itself is 16 hundredths? What's the numerator going to be? Let's just focus on the numerator. 4 times 4. And what's the denominator? Okay. So therefore, what is the square root of 16 hundredths in decimal form? In fraction form, it's 4 tenths. In decimal form, it's 4 tenths. Okay. Just to make sure, I'll grab my calculator. What is the square root of 16 hundredths? The answer is 4 tenths. And our last exemplar from section 2.4 says, estimate the square root of 0.34. So when we have that, we're going to use our number line again. Right? What perfect squares do we know fit between 0.34? Do we know any decimal perfect squares? Well, what is 0.25? What's the square root of 0.25? Does anyone know? Probably like decimal 5 is correct. So the answer is 0.5. And what is the square root of 0.36, do you think? That's right, 0.6. So that number 0.34 has to fit between there. Now what we're going to do here is I'm actually going to add just an insignificant 0 there. I'm just going to put it there because it's going to help me fine-tune my estimation. If I had to put this black dot somewhere on that number line to represent the square root of 34, would you think it's right in the middle? Over here? How about over here? How about right there? Does that look about right? What? Where would you put it? More right? No. How many agree that's pretty darn good? I agree. Thank you very much. All right, whatever. Deacon's smarter than I am. Big deal. Who cares? What number do you think that is based only on this and this? You think 67 or 57? Which one is it? 57. How many agree 0.57 seems reasonable? 0.57, 0.58 is correct. So therefore, the square root of 0.34 is approximately equal to 0.57. We're going to write that down, and hopefully that's right. How are we going to calculate it? Yeah, we're going to grab our calculator. All right, here we go. Drum roll. Here we go. 0.34. Square root. What is it? Rounded to the nearest hundredth. So the actual calculation, it's still approximate because we're actually rounding. It's approximately 0.58. Was our estimation good? It was. It was very good. It was very good. But that's how you do it, just like that.